And I'm going to start recording. We're going to go into a quick review of classifying triangles. Okay, that's what we're going to focus on. That's what your assignment is going to be on today. Let's start off by talking about there's a couple different ways that we can classify a triangle. We can either classify it based on its angles. We can classify it based on its angles, or we can classify it based on its sides. Okay. So let's think first about the angles. Okay. There's three different types. We have acute, we have obtuse, and we have oh my gosh. Sorry, 1 second. And we have a right triangle. Okay. And then when it comes to the sides, we have what we would call scaling. We have equilateral. And we have, oh my gosh, I'm blanking on the last one here. Blanking on that last name there. Let's look it up. Triangle types. Isosceles. There we go. Okay, so let's start with triangles that are acute. So just to begin with, what is an acute angle?
Anything under 90?
Anything under 90, that's right. So a small angle, anything under 90. Okay, when we have an acute triangle, we're going to have a triangle like this where all of the angles are going to be below 90. So I mean, we could say 60, 60, 60, right? And remember, all the angles inside have to be equal to 180. So it could be that they're all 60, or we could say that maybe, I don't know, like, let's say one's 54, one's 66, and then 60, right? Doesn't really matter, but as long as they're all smaller than 90, we have an acute triangle. Now let's look at something that's obtuse. And again, what is an angle that is obtuse?
Is below 90.
An angle that is obtuse?
This is it's above like
Above
180,
90.
I think.
Yeah, it's above 90 actually, right? So remember, I mean, all the angles inside a triangle have to equal to 180, okay? So a triangle that's obtuse would probably look something like this, right? Where maybe like this angle right here could be like 108 or something like that, right? So as long as we have one angle that is obtuse, then we have what we would call an obtuse triangle, okay? And I don't know, maybe there's even some that could be like even wider, like something like this, where the angle right there is like maybe 130 or something, pretty big, right? But it's all based on the fact that one of the angles has to be obtuse or bigger than 90 degrees. And then finally, we have the ones that we usually see the most, especially when we're talking about Pythagorean theorem and all that, are right triangles. What are our right triangles going to look like? Or more importantly, what's how do we know that something is a right triangle?
If it has 90 degrees
It's
in
a
it.
90 degrees angle.
It has to have one of those, right? A little square, which makes it a 90-degree angle. Okay.
Yeah.
So that's our 3 types of triangles based on their angles. Then we also have 3 types of triangles based on the sides. And of course, some of these can be the exact same thing, right? If we're talking about scaling, scaling can also be acute. Scaling can be obtuse. It just depends, right? Well, let's start off with an equilateral triangle. So an equilateral triangle is going to be a triangle that has sides that are the same. So all of these sides are going to be the same. Of course, when we're talking about equilateral, lateral being the sides, and of course, when we say equi, that's like the same, right? Equal parts. Now a triangle that is isosceles, what's important about those is that they have 2 sides that are the same, but then the last one, could be bigger, it could be smaller, it just depends, right? And then finally, we have what we would call scaling, which is a triangle that it has no equal sides. So none of the sides should be the same, right? It's going to look in different ways. So let's think about how that looks like, okay? And let me share what I posted in Google Classroom. Okay. So for example, let's look at the first 3. So 1, 2, and 3. We have 3 different examples. One of them is a right angle. One of them is a right triangle. One of them is an obtuse triangle, and one of them is a acute. So which one is which? Let's start with number 1. What kind of triangle is that?
A right angle.
Right triangle, right? What about number 2?
An obtuse triangle.
Yes, obtuse. And that's because we have that angle of 103. That's more than 90 degrees, which makes it an obtuse triangle. And then finally, number 3 would be what kind?
Acute.
An acute. Good. That's because all of the angles are less than 90 degrees. Okay. So let's look at another example where we have D. It's telling you, okay, what's triangle DFG? So D, if we're looking at the entire thing, DFG, what kind of triangle?
Oh, I was cutting it off. Okay, I was cutting it off. It's the right angle.
It's a right, not right angle, but right triangle.
A right triangle.
Right. Okay. What about
DEG.
right? So DEG. Let me do that with another color. So
Obtuse.
DEG.
Acute.
That would be acute, right? Because it's
Yeah.
54, 68, and we're not entirely sure what that is.
It's like
Okay.
a half of
Yeah, it's like
half of it.
all we know is that we have 2 acute angles, and then the last one, I mean, it's going to cut into the 90 degrees, so we know for a fact that it has to be less than 90. Okay. And then finally, we have, and let me do that one in green, EFG. What kind of triangle would that be? EFG.
Wouldn't it still be a acute because it's not over 90?
So the question is how big is that angle? And we can actually figure that out. Does anybody have an idea how we can figure that out?
I forgot.
Because we're looking at this, but think about the entire thing right there. What do we have there?
It looks like a. What is it called? What is it called? Shit. Oh,
You can minus 32 and 36, so 180.
Right, right. We could do that. So if we subtract, remember that all the angles inside have to be equal to 180. Right? So if we subtract 180 and 180 minus 32 minus 36.
112.
Right, 112. So if it's 112, what kind of triangle is it?
Obtuse.
Exactly. Now there's another way that we can figure this out as well. If you notice, we have a straight line right there, right? And we know that this angle is 68. So we can actually subtract 68 from 190 and 180. And that should also give us 112, right? Because both of those angles have to be equal to 180. All right. Now let's look at this one right here. Now we're talking about lengths, okay? So EGF, EGF. What kind of triangle do we have there?
EGF. Acute.
No, now this time we're classifying by the sides. So that's three different types of triangles, right? We have scaling, we have isosceles, and we have equilateral. Equilateral. Okay. So EGF. So let's think about that. We have two sides, 13, and this side that is also 13. So we have two sides that are the same and one that is different. What kind of triangle would that be? As a review, scaling triangles have sides that are all different, so different sides. Isosceles triangles have two equal sides, and equilateral triangles have all three that are the same.
So the isosceles one.
Isosceles.
Yeah, isosceles.
Yes. Okay. What about DEF? So triangle DEF.
But how will we know if they're all equal or not?
Sorry?
Because it only has one. How will we know if they're all equal?
Okay. So we know, pay attention to the lines, right? So we know that those two are equal, right? So G and E is 13. That means that E and F also has to be 13. Now look at these two lines right here, right? That also tells us that both of those are equal. So 20, if GF is 20, then that means that DF is also 20. Okay, so based off of this, we have a side that's 14, one that is 13, and one that is 20. So what kind of triangle would we have here? If all the sides are different, we have a scaling triangle. Okay. And finally, let's look at the entire thing. D, F, G. Now, between these two, we know that this is 13, this is 14, so the whole thing has to be 27. And again, these two are the same. So this is 20, then this also has to be 20. So again, what kind of triangle do we have here? We have two equal sides, and the third side's different. So what type of triangle is that? Any idea? Be an isosceles. Okay, so we need to make sure. Again, this is all reviews, so we really need to make sure that we know how to classify each of those triangles. And so that's what your assignment is going to be today. It's on Delta Math, and it should be very easy, okay? So looking at this, for example, you're going to have to classify each triangle based on the angles and the sides. So looking at this first example, we have all sides that are the same. So we have an equilateral triangle. And then we have all angles that are less than 90 degrees. So we have an acute triangle. So we would say that this is an acute and an equilateral. Or at the very minimum, we just have equilateral. Now, one of these, for example, we have a 90-degree angle, okay, which makes it a right triangle. And now looking at all the sides, they're all different, which would give us a scaling triangle. So we have a scaling right triangle. So putting those two classifications together give us the type of triangle that we have there. Okay, this is what your homework will be on today. Okay. Should be pretty easy. Try to get in there and then just go ahead.